This is 2.6 transformations of functions, part 2. So if you have not seen part 1, go back and watch part 1. This is the ending part of it, transformation. So this is also talking about labeling functions and specifically even and odd functions. So a lot of times people think, because of the even and odd numbers, they think the functions are related to that, and that's not really the case. So for instance, we know that like if you had x squared, y equals x squared, a lot of us might think, well, that's an even function. And it happens to be an even function, but it's not because of the exponent being a 2. So you have to look at the definition of even to be able to find out if it's an even function. So here's the definition. So let f be the function. So f is even if f of negative x equals f of x. And so we talked about earlier a parabola. I kept referring to a parabola in the first video. And if you notice the general case of the parabola, like the point 1, 1, and then the point that reflects it is negative 1, 1. So notice the x is it's reflective about the y-axis here, the normal parabola, y equals x squared. It's reflective about the y-axis, and notice when I substitute negative x in, I end up getting f of x. It's the same function. So an even function has that characteristics where it's symmetrical about the y-axis. So if you want to make yourself a comment, it's symmetrical about the y-axis. Now, if it's an odd function, notice if I substitute negative x into the function, I end up getting the negative of f of x. And if that's the case, it happens to be an odd function, and this is symmetrical with the origin. And one thing that you might want to notice, especially with the origin, if you think of this like as a clock or something like that, what you're doing is you're rotating it. You're rotating the object 180 degrees, or on a clock, 6 hours. So if you literally take a point over here and you rotate it, it ends up over here. Same thing with this point. If you rotate it, it ends up here. And you literally just rotate them 180 degrees. That's what the graph looks like. Now again, this is not about graphing right now. I just want to see if it's an even function or an odd function. So let's look at a couple examples. So here, determine whether the functions are even, odd, or neither. It may not be an even function, or it may not be an odd function. And so just as a reminder, so if it's even, we just wrote this. So f of negative x will end up being f of x. That's the one thing I always check for. I always plug in negative x where the x is to be able to do that. And then if it's odd, f of negative x is going to be negative of f of x. So either way, we're going to substitute negative x in for x. Either way, we're going to do that. So let's look at letter A. So on letter A, if I take this function, f of x, but I'm going to substitute it in for negative x. So wherever x is, I'm going to substitute in for negative x. And notice this right here is still going to give me negative x to the 5th, and this is going to give me negative x. Now notice what this is. If I factor out a negative 1, because they both have a negative 1 in common, I end up with x to the 5th plus x. Well, that's what f of x is. So notice when I substitute negative x in, I end up getting negative f of x, and notice that happens to be an odd function. So this is an odd function. All right, so that's letter A. Letter B, I'm going to take g of x, but instead of just x, I'm substituting negative x in. And notice what I'm going to get. I'm going to get negative x to the 4th power is a positive x. And notice that it literally is what g of x is. That is exactly what g of x is. So this literally is when when you substitute in, you get the same exact function is, so this happens to be an even function. All right, so let's look at letter C. So letter C, again, I'm going to substitute negative x in, and you're going to literally replace it with a negative x. The x is with a negative x. And then simplify. So that's negative 2x. Negative, and again, make sure you follow the order of operations. So that's x squared. If you want to factor out a negative, that's fine. But notice this right here is not. It's not either one of these. It's not. It doesn't equal h of x to begin with. It doesn't equal negative of h of x. So it's neither one. So this is neither even or odd. So again, in general, a lot of people look at the exponents and they just want to make a general rule for this. But I highly suggest that you literally make that substitution and then work it out to see if it's an even or an odd function.